Looks like we got ourselves another problem here, Duck.
What is it?
2 robbers stole some money from a bank and are getting away with it. They left calculus problems for our men to solve, but they're too dumb.
Like me, sir?
Yes. Okay, let's go get them.
Okie dokie.
Hey boss, look, I think we found our first clue.
Oh, what do we got here, Duck?
Rolle's theorem.
Rolle's theorem, our first clue. Alright, so Rolle's theorem is where f of A equals f of B and C prime equals 0. But the interval also must be differentiable. Who could ever forget that?
Yeah, good job.
Oh, first robber, dude.
Good work, Duck.
No, chill, man.
Tell us where the money is, boy.
First, solve this problem, pig.
Okay.
We escaped in a van at 50 miles per hour, and then at 50 miles per hour later, find the rule of change. Rate.
This is rate of change.
Why do you look at you?
Rate of change. Alright,
Find the rate of change.
So that was in 4 minutes, so that's 1/15 of an hour.
Okay, let me help you.
Cool.
MVT is special because the mean value is equal to 0, just where the slope of a point is equal to 0.
Thanks. So, I have to find the average velocity between 50 and 50 miles per hour?
Yeah, bro.
Okay. So, if we just do this... Did I get it?
Yeah.
Cool.
You got it, bro.
Thanks.
No problem, cop.
Alright.
Don't arrest me.
You're the second one, boss.
The money is here, but I need help with this problem before you get it. Can you help?
Okay.
I need to know the first derivative test and the second derivative test, but I don't know them.
Well, first you derive, then set it equal to 0. X is the critical numbers, then you set up your intervals using those and the domain.
Oh,
Wait a minute.
yeah, and from your intervals you choose test values and next plug them into the f prime. If the prime is positive, it's increasing. If it's negative, it's decreasing.
Oh yeah, I totally remember that from months ago. And the second derivative test is for concavity, right?
Yes.
Yeah.
Okay, I got this.
Alright, what do we got here? Okay, first, write the original function. Alright, good job, Duck.
Thanks.
Now differentiate and set f prime equal to 0.
Oh, this is pretty easy.
Equal to 0. Good job. Alright, now we gotta find out what x equals, so why don't we factor this bad boy?
Whoa, we got a 3x here and here.
Look at that common term right there.
So let's take that out.
Great. Now, solve for x and get your critical numbers.
Looks like you got 0 and 1.
Good job.
Is that right?
I'm pretty sure you're on the right track here.
Okay.
Now plug your numbers into f prime, so we do the first derivative test.
So you plug this into this.
Yes.
Okay. That is positive. It's 0. Okay. What?
No, you
Wait,
choose
hold on,
a number.
Wait.
No, we choose a number in between.
Yeah, so
in
you
between
can't
here.
have
Alright,
that,
wait,
so
here,
you
wait,
have
wait,
to-
wait, here.
Fuck!
Now we're going to do our first derivative test, Duck. So choose values in between our critical numbers to determine if they're positive or negative.
So let's put 1/2 into this equation. Okay. That's positive, right?
Actually, I think it's
It's
negative.
negative. Wow. Crazy.
Look at that.
Alright, so let's put 2 in. Oh, that's positive. And let's put -1 in. That's positive.
Alright.
Okay, so it's increasing from negative infinity to 0 and 1 to infinity, and decreasing from 0 to 1.
Good job, Duck. You've solved the problem.
Is that it?
Yeah. It's pretty hard, boss, so I'm going to let you do it. Maybe you should rewrite the original function.
Alright, Duck. Let's see where that gets us. Okay.
It's pretty good, boss. Maybe we should differentiate.
That sounds like a great idea to me, Duck. Let's do it. Alright, now we're gonna rewrite that so it doesn't look so messy.
And that's the first derivative, right?
Yes, it is, Duck.
Maybe since we're doing the second derivative, you should differentiate it again.
I think that sounds just great. And there you have it, Duck. This is our second derivative.
It looks pretty complicated.
Yeah, it does. And we're not even done yet. Now what we have to do is
Like a timeline.
you mean a critical number chart, Duck?
Yeah, a critical number chart, because that's what it is.
Mm-hmm.
Timeline.
You're darn right. Alright.
Hey, I think that's negative.
I think it is. In between here, the values are negative.
I think so too.
And
That's
I believe
downward.
over here, it's positive.
Oh yes, sir, it is.
And over here, it's positive once more.
You were right.
So what do we get, boys? We get concave upward,
Concave up.
concave downward,
CD.
and concave upward.
CU.
And that is going to look like this. Concave down, concave up. Okay, now that we've done our second derivative test and plugged in for our critical numbers, we can graph it while determining the concavity. And if we've done this right, according to this graph, the money should be
What the hell?
right here.
Whoa, I'd be standing on it the whole time.
Aw, shucks, Duck. We got the money.
Shucks. Oh, shucks, Miss York, we got the money.
Freeze, you're under arrest. Let's go, boys. For robbing a bank. Me? Yes,
How'd you find the money?
we did calculus.